Welcome to this video covering algebra review. This quick review will cover topics such as slope and graphing and solving equations. We're actually going to start with solving some equations. These three problems are pretty basic. They are two-step equations. They are called two-step equations because it should only take you 2 steps to isolate the variable. So we always start with the addition and subtraction first, and then we deal with the multiplication or division, remembering that the goal is to isolate the variable, which simply means to get the variable by itself. So when you have x equals by itself, then you know that you have completed the equation. Common mistake with the second problem is that students see the subtraction and they want to add 17 to both sides. Adding 17 to both sides will not eliminate the 17 from the left-hand side. You must subtract it. So that's the only way to eliminate the 17s. That negative belongs to the x, so you have to bring that down. And it is important to bring it down because that's actually a -1, and then you have to divide both sides by the -1 to find out that x equals positive 14. We don't want to know that negative x up here. We don't want to know that negative x equals negative 14. We want to know that x equals 14. Finally, this last example I chose because of the fraction. So first thing I'm going to do is add 6 to both sides to get 2/3 x equals 12. And then remember that when we are undoing this multiplication here, we're technically dividing by a fraction. So you do have choices. You do have access to a calculator. So you are welcome to just show dividing both sides by 2/3. And then as long as you are entering it into your calculator correctly, you should be able to do the work, get the correct answer. However, I'm going to show you that, remember back in pre-algebra or even later middle school, you learned that when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So if we make the 12 into a 12/1 fraction, we multiply by 3/2 on both sides because that is the reciprocal of 2/3. You do that so that over here on the left-hand side, 3 times 2 is 6, 2 times 3 is 6. This simplifies to a 1. So you're just left with 1x, or just x on the left-hand side. And then on the right-hand side, this does not always simplify, but in this case it does. 12 times 3 is 36. Divide that by 2 is 18. So x equals 18. These three equations are a little bit longer than the 2 steps on the previous slide. We have variables on both sides. We've got grouping and variables on both sides. And then there's only variables on the left-hand side, but it does have grouping, and then we are going to have to combine some terms. So these are just a little bit longer. The thing to keep in mind here to remember is that we're going to simplify first, and then we will solve. So I'm going to show that in 2 different colors here so you can recognize when we're actually simplifying versus solving. So simplifying in this first problem, it's -6x plus 18 on the left-hand side. I can do nothing with that because they're already like terms, or sorry, they're not like terms, so I can't do anything with it. Same thing on the right-hand side, 2x minus 6. There are no like terms, so I cannot simplify that. So we're going to go straight into solving. Some of you may have learned to put a bar down the equation, and that just helps organize your work when you are moving through the solving. So I chose to subtract 2x from both sides because I just like to keep my variables on the left. You also could have added 6 to both sides. Please make sure that you are careful with your negatives that need to come down when they do need to come down. And we're just going to keep solving now by subtracting 18. So -8x equals -24. We divide both sides by -8. X equals 3. So this whole problem was just solving. And when we say solving, we're meaning we're using inverse operations to isolate the variable. We're undoing operations. So this 2x was positive, so I was subtracting it from both sides. This 18 was positive, so I was subtracting it from both sides. And this -8 is being multiplied by x, so I divided it on both sides just to get x by itself. Now, in the second problem, there is some simplifying to do here with this distribution on the left side. Nothing on the right. The right-hand side is completely simplified. So all I have to do is distribute the 3 by multiplying it. So I'm going to get -12x plus 15. And then I'm just going to rewrite the right-hand side. Nothing is changing there. But now both sides are simplified, I can go ahead and start solving. So notice that I switched colors because now I'm going to start using inverse operations to get variables on both sides to isolate the variable to finally get x equals 1. Last example, we have a lot of simplifying to do, but I'm going to start with this distribution with -2. The 18 on the right-hand side is simplified. It's just the number 18. So I'm going to focus on the left-hand side here, and I'm going to simplify by distributing. And then I'm going to have some like terms to combine. My x's can be added together, and my constants can be added together. And this is still simplifying, so I'm going to get positive 2x minus 6 equals 18. The positive 2 is coming from negative 2x plus 4x will give me a positive 2x. Negative 2 minus 4 is going to give me negative 6. Now the 2x minus 6 is simplified because they are not like terms. I cannot do anything further with that. And the 18, as said before, is already simplified. So now I can solve. Because the variable is only on one side of the equation, I can just go straight into inverse operations with my constants by adding 6 to both sides and then dividing by 2 to get x equals 12. Just a note about all that work I've been showing as solving these equations. If you are a student who feels comfortable and strong in your algebra skills, you don't have to show, for example, like you're subtracting 2 from both sides of the equation, but you do need to show what you get after you have subtracted 2 from both sides. And if you have questions about the amount of work that is required from me, you're just going to have to ask as we go along, and you'll get to know some of my requirements as we go throughout the course. So just keep that in mind, that I'm not going to make you show every single little thing that you are doing, but it is important to show your results as you go through. Somewhere in the middle of the course, we will be needing to review slope and writing equations and graphing equations for lines. So we're going to go ahead and review slope now. The letter M gets used for slope, and this is the formula. And we remember that we are using the little 1s and 2s to simply number the points. So x1, y1 represents the first xy point. x2, y2 represents the second xy point. So I'm just going to go ahead and plug these values, -2, 0, and 4, into this equation. I will take this opportunity to remind you that when you are subtracting a negative, it is the same thing as adding a positive. So you will not see me show double signs anymore. I will simply show it as an addition problem. And we just want to remember to always simplify our final answer. This second example here, you just want to be careful with all the negatives and which ones stay subtractions and which one turns into additions. So you just want to be careful, make sure you're using the formula correctly. So moving on, we're going to get -2 over 6. So that simplifies to -1/3. A quick note about simplifying fractions. The graphing calculator does not allow you to write fractions in any form other than improper fractions. No mixed numbers. Decimals are fine unless you're rounding, so we just try to use the fractions. So when you are simplifying fractions like the 2 over 6, you can use the graphing calculator's math button. So you press this button right here, and then you're going to hit the enter button twice. And what that does is it will turn whatever it is you are working on into a fraction, and it will be always in the simplified form. We're going to start with graphing our lines. Now we're going to focus on slope-intercept form, which is y equals mx plus b. Keeping in mind that we've already seen m represents the slope. That's why it's called the slope-intercept form. The intercept part comes back at b, which is the y-intercept. So that's where we're going to start all of our graphs. So on this first one, the -3 is my y-intercept. So that is going to be where I start my graph on my y-axis. I'm going to put my first dot down at -3. Then I will use my slope of +4, and I'm going to write it as a fraction because remember, slope is rise over run on a graph. So I'm going to count up 4, and this is just bounce counting, like 1, 2, 3, 4, and then I'm going to go to the right one and I'll put a dot there. And we can continue to do that to get more points going in either direction. So we started here at the y-intercept, up 4 into the right 1, up 4 into the right 1, up 4 into the right 1 to get these 3 green points. But I can also go down 4 into the left 1. Like if I started up here, I could go down 4 into the left, down into the left, down into the left. So I can continue that and get this point down here, which I can then connect to make my line. Final example has me starting my y-intercept at +2. So I'm going to go up 2 and put my first dot there. My slope in this example is negative. So I'm going to start at my y-intercept and I'm going to go down 1 and to the right 3, down 1 and to the right 3, continue that pattern as long as I can. Then I will also go back and do up 1 and to the left, up 1 and to the left. Because it is a negative slope, I should end up with a line going down from left to right. So the line for y equals -1/3 x + 2 is this green line here. Thanks for watching the algebra review video. It certainly does not cover everything that you've learned in algebra that you could see again in geometry, but these are some of the strong points. You have to be really good about solving your equations, and some graphing does show up a little bit later on in the semester. Again, thanks for watching, and if you have any questions, be sure to ask.